February 4th, 2017. I was surprised I didn't have this as a basic principle, but I'll read it out for you guys. It's a lot more interesting to have me read it than it is just to read it yourself, because I can add things to it and whatnot. The time principle of planet formation. The abstract is, since stellar evolution takes billions of years, and planet formation is stellar evolution in the general theory of stellar metamorphosis, it takes billions of years for a planet to form. And this was very important for me to clarify, because in astronomy, planets just clump together and then that's it. There's no real time frame for it to go down. And worse off, sometimes I read articles where we'll have a planet forming in 1,000,000 years. That's ridiculous. It takes billions of years for a star to lose the vast majority of its heat and mass, given it does this absent a younger, hotter host, speeding up its evolutionary timeline significantly by ripping it apart before it can fully differentiate and form the core material. For example, if you have a hot sun-like star and you have a hot Jupiter around it orbiting really close, that sun-like star will rip it apart before it can differentiate and form the core. It'll just keep on ripping the outer atmosphere apart, ripping it apart, and there's nothing to layer onto the central regions. So what you'll end up is a tiny little thing, and with the iron or the nickel in the center, and it won't be big at all. It'll be like a small moon. That's probably how those moons came to be. In stellar metamorphosis, the stars that have lost the majority of their heat and mass are similar in size, composition, differentiating in mass to the Earth, Venus, Mars, and Mercury. Since they are labeled as planets by the establishment, it can be stated that planets take billions of years to form. This understanding has major consequences to the status quo of academia. The status quo is very skewed, and we all know this. It means that we will never witness planet formation as a complete process, but we can view planets in different stages to their evolution. And that's very important. When the JWST or the James Webb Space Telescope goes up and it has a very high functioning viewing capacity with its near-infrared mirrors, they're going to constantly claim that they see planets being formed. The truth is they ain't going to see shit, because planet formation doesn't happen outside of a hot stellar body like a star. It happens internally. And it takes a very long time. So not only are they going to be full of shit if they see it actually happening, but happening in a short amount of time. So there are two avenues where we can call them out when they start giving the media more bullshit. An analogy to this would be to view trees in the forest. You can walk around in a forest and you will not actually see the trees growing, but you can infer their growth from smaller trees in the vicinity. The same goes with stars. We can infer their evolution by looking at the ones that no longer shine. Only it is backwards during the main evolutionary sequence. Once the star reaches blue giant stages, it begins shrinking and losing mass. This means it will become smaller, colder, and less massive as it evolves. With trees, they become bigger as they grow and age. The oldest trees are the biggest because they continually add mass to them as they grow. But since stars lose mass as they evolve, as per the mass loss principle, the oldest stars will be the smallest ones as well as the coldest. And it's very simple to understand that. For a tree to grow, it gains in mass. It gets bigger and bigger and bigger. But with stars, when they evolve, clearly we watch them losing mass to solar winds, solar flares, and coronal mass ejections. Well then, they're going to be smaller as they evolve, are they not? It's common sense. Stuff that loses its mass gets smaller. It would be like watching a tree trees don't get smaller, but imagine if you could reverse watching a tree, if you could set up a time lapse of a tree growing, and imagine watching it go in reverse, and then become the acorn, and then pop up off the ground back into the tree again. That would be interesting. That would be one hell of a long time lapse, though. In academia, any claims of seeing planets being formed are therefore false under this principle. The planet formation process happens internally inside the evolving star, So seeing planet formation will never occur even if we could speed up time. We can only infer the processes by studying the ground or high atmospheres of old or younger stars. This is in essence playing detective. By looking at the direct clues on the Earth itself, we can discover what happened to it in the light that it is left over core of a long evolved star. And this is very basic to understand. I want my listeners to realize that when academia starts giving these publications to the media is going to skew it in two very, very damaging regards. The first one is the idea that somehow they can see the planet formation happening, which is completely false. Unless they're actually looking at a birthing star, then they're not actually looking at planets being formed, planets being older stars, because it happens internally inside the star. You can't see outside what's happening internally. It's too dense. You can't get a satellite in there. You can't get a probe in there. As well as it takes too much time. Even if you cut the star like a giant 10-layered chocolate cake and take a big slice of it and look inside of it, you wouldn't see anything happening. It takes too long. It takes many billions of years to differentiate the interior into its component iron, nickel core, magnesium, and heavier elements, or heavy elements, and then lighter and lighter as it goes out from the internal regions. So keep in mind, look, make sure you pay attention to when those articles start coming out after the JWST goes up, which is going to be in late 2018, I believe. But it's going to happen. Anyways, I think I made this talk long enough, but I got these books from the library. I'm going to start reading them, and I'll report back to you guys in a few more days. All right, later.